In this video clip, we'll talk a little bit about the fossil record. Fossil record documents the history of life. Fossils are just evidence of once living organisms, and it can reveal to us how evolution has occurred over long periods of time. Fossils are preserved remains of past life on Earth. This does not necessarily mean a whole organism is preserved. There are many types of fossils. Sometimes we have mineralized tissue, petrified soft parts that have become mineralized, like the dinosaur bones we see at the museums. Other times we have casts and molds. Sometimes there are trace fossils, which are indirect evidence. And when we are very lucky, we get preserved specimens that might be encased in amber, frozen, or mummified. Fossils form in many ways. Compression is when a fossil or an organism is put under pressure over a long period of time. The sediment covers that particular organism, compresses it, and forms it into sedimentary rock. We can see an example of that here with this leaf. Petrification is when an animal or organism dies and is buried. Water containing dissolved minerals seeps through, and organic matter is replaced by minerals and turned to stone. Impression is when an organism dies, making an impression or indent in mud. After the animal decays, and the organic matter is gone, the mud has hardened, leaving this imprint and evidence of the organism that was there. A cast is kind of similar. It starts out with the organism that sinks into soft sediment. As the animal decays away, the imprint is then filled in with mud, and the mud hardens and turns into rock, giving us this cast of an organism. Rarely, intact organisms are preserved by being buried suddenly in the absence of oxygen. These conditions minimize decomposition and prevent scavenging. Sometimes we also see whole organism preservation in substances such as amber. So other times they can be mummified or frozen. The fossil record shows us transitional forms. Transitional fossils display intermediate traits between an ancestral form and its descendants. Often this group will have key characteristics of two major groups. This Archaeopteryx is a great example. This animal is classified as the first bird. It has characteristics of modern-day birds, such as wings and feathers, but it also still has characteristics of a dinosaur, such as the clawed toes on the front arms and the teeth in its beak. However, our fossil record is not a complete record. The fossil record is actually biased. Generally, organisms are going to decay when they die. It takes very specific conditions for fossils to be formed, and there are certain parts of organisms that are more likely to fossilize than others. If a fossil is formed, and that's a big if, there's also the chance of it being destroyed or damaged over time. Fossils are more likely to form if a species exists for a long time period in Earth's history, if it is abundant and widespread across many regions, and if it has hard parts such as shells or bones. The fossil record is literally set in stone. It is contained in the sedimentary rocks or the strata layers, and certain strata layers are very rich in fossils. When we date fossils, there are two major types of dating that we talk about. Relative dating looks at the fossils in the strata layer. We use the law of superposition, which states that deeper rock is older, to help us place fossils in different categories or timeframes. Sometimes we also use fossils, called index fossils, to relate different strata across the world. We use this to define key time periods in the strata. For example, trilobites are always found in a certain layer. For fossil to be an index fossil, it has to be distinctive, globally spread, highly abundant, limited to a particular geologic time, and is robust and well preserved. Trilobites are a great example of this because they are global, well preserved because of their hard exoskeleton, and they're only found in a certain geologic time frame. The second type of dating is absolute dating, also known as radiometric dating. The absolute ages of fossils can be determined by calculating half-lives and determining how much of a parent isotope is left compared to the daughter isotope that is formed as the isotope decays. Each isotope has a known half-life, which is the time required for that isotope to decay by 50%. A common example of absolute dating uses carbon-14. Radiocarbon dating can only be used to date fossils up to 75,000 years old. If you're looking at an older fossil, you have to use other isotopes. For example, uranium-239 can be used to date very old fossils. In this video clip, we talked a little bit about the fossil record.